Hello Math 7 students, this is Open Up Resources, Unit 2, Lesson 5, 2 equations for each relationship. This is the third video covering this lesson and it will be our last. We left off last time finishing up with the water cooler problem where we wrote two equations, and I want you to pay attention to the similarities between those equations. Here we have T times 1/3 is equal to W. And W times 3 is equal to T. Recognize those relationships. 1/3 and 3 are reciprocals. And here the W is alone, so the constant of proportionality is multiplied by T. Here T is alone, so the constant of proportionality is multiplied by W. So if you have one equation, ultimately I would like you to be able to take a look at that equation and manipulate it to find the second. You can do that by noticing 1/3 and 3 are reciprocals. And the W and T simply change places. That's going to be really important for what we're doing today, especially for our cool down. So please make sure you remember that. Let's take a look at 5.4, feeding shrimp. At an aquarium, a shrimp is fed 1/5 of a gram of food each feeding, and it's fed 3 times each day. So 1/5 of a gram of food each feeding, fed 3 times each day. How much food does a shrimp get fed in one single day? Jada. Say that again. It is not 1/5. Help her out, Gavin D. 3/5. 1/5 of a gram at each feeding, but that happens 3 times in a day. So 1/5 and another 1/5 at lunchtime and another 1/5 at dinner time is going to be 3/5 of a gram of food in one day. Use that information to fill out the table. We know that one day will be 3/5 of a gram of food. Before you fill out the rest of the table, you should ask yourself that question that we always ask at the beginning of a problem like this. How does a 1 change to a 3/5? Hagen. We multiply by 3/5. Any guesses what we should probably be doing everywhere on that table? Probably the same thing. Make it happen. And 30 times 3/5, sorry, I'm jumping ahead, 7 times 3/5. We'll wait. We should have more fingers working calculators, paying attention. Stephen? Let's keep them improper fractions, please. Mixed numbers are good for nothing when we're calculating, so let's keep an improper. Nope, it is not 7/5. Go ahead, Dakota. 21/5. We cannot calculate with mixed numbers, so I always like them to be improper fractions. 30 times 3/5 is equal to, Sam? Just 18, right? Not a fraction, just 18. I hope that you're able to answer this question. What is the constant of proportionality? We literally needed to know the answer to that question in order to fill out the table. What is the constant of proportionality, Savannah? It is 3/5. Because every time I go across this table, I'm multiplying by the number 3/5. A question came up. Instead of 3/5, can I use 0.6? The answer is yes and also no. If you, as we saw here, if you change them to decimals, you don't get to see the relationship that is so important. We had 8/5 as a fraction, and we saw the reciprocal 5/8, and we were able to see that relationship because they were fractions. Are decimals wrong? No. But if you use the decimals, then you're not going to see that relationship. I wouldn't change it, but I would do both. I would make sure that you have the 3/5 written on there as well. So what does this information tell us about the situation? And this is what I want to draw your attention to and make a connection. That 3/5 is important because it's across the table from the 1. And this is what's really important. This tells us it's 3/5 of a gram of food per or for every 1 day. That tells me that this is the unit rate. We've talked about this before. The unit rate is the same as the constant of proportionality. Recognizing that and understanding what that means for each problem will also help you be successful. Now the question is this: what if we switched the columns in the table? Is that a question or a comment? Okay. Is that relating to this problem? Okay, go ahead. You're answering this question already? We're not there yet. Sorry, you're going a little bit too fast. You are correct, but shush, don't tell anyone else. Let them think for themselves for a second. If we switch the columns in the table, and do you see how much space I've given you? So could you recreate and switch the columns in that table? Do you need to? Jada, when you answered that question, did you switch the columns in the table and rewrite that column? Exactly. Because we've been through this enough times that even though I've given you the space, I hope you realize it's not necessary, because we've seen when I switch the columns here in this table, what's that relationship? It's reciprocals. And what about here? When I switch the columns in these tables, we saw that they were reciprocals. So hopefully we're at the point now where we no longer have to actually physically rewrite and switch those columns. And we know that the constant of proportionality, if I switch those, is going to be, go ahead, Jada, 5/3, 5/3. And again, if you were to write this one as a decimal, this is going to be 1.6 over bar. And if you keep them as a decimal, do you see that reciprocal relationship? You can? 0.6 and 1.6 over bar, those look like reciprocals. Looks like we're just flipping them. No. We can't see it. So that's why I like fractions, so you can see that relationship. But then sometimes it is easier to type something like that into your calculator. So we didn't have to switch the columns, but let's do just a very kind of shortened version of that, just to prove that it ended up being correct. So I'm not going to copy down everything. We have days on the left, so switching that, days is going to be on the right. We had food on the right, so switching that, that's going to be food on the left. And I'm just going to pick one. I like this one because we're dealing with some nice numbers here. So the food in grams is 18. The days is 30. Okay, and I didn't complete the entire table. I'm just doing just enough to kind of check my answer. How does that 18 change to a 30? Well, we do technically know, right? We must be multiplying by 5/3, but let's pretend like we didn't know, and we would work backwards. And we'd have 30 divided by 18. What does 30 divided by 18 give you? Surprise, surprise, it gives you 5/3. But that's the most important thing of all, is recognizing that this was just what we had to do to check our answer. We didn't have to recreate that entire table because we recognized that when we flip the columns, we're going to get the reciprocal for the constant of proportionality. Reciprocal. Let's write that down because it says explain. So when we flip the columns in the table, thanks for writing this down. we flip the constant of proportionality to its reciprocal. Easy enough, right? So now, this next part says if D is used for number of days and F is used for the amount of food in grams, write two equations that represent this relationship. This is the only reason why I made this little baby table. Because whenever we want to write an equation, I've already told you, take the information to a table first, and then from the table, we can write that equation. So you need to write two. Let's keep ourselves organized. Use this table here for your first equation, and use this table here to write your second equation. Pause the video to work on writing these two equations and continue to watch the video once you have written them both. Okay, it says to use D for the number of days. So that means as I'm looking at my tables, the days column gets the label of D. And it says to use F for food, so that means the food column gets the label F. And for our first equation, who's brave enough to tell me what they wrote down so we can check it? Good, not enough hands, but I at least am happy with this amount. Let's start with Jackson. You got it. That's perfect. Completely perfect. Because as I'm going forward in this table, I'm starting with D. I'm going forward, multiplying by 3/5, and I end up in the F column. So make sure you're watching this. If you wanted to, could you write it like this? F equals 3/5 D. Yeah. Second equation. You can use the table if you want. After we do that, we're going to hopefully find some other patterns. Let's go to Hayden. F times 5/3 is equal to D. And if we wanted to, we could reverse that and say D equals 5/3 F, right? Perfect. These are perfect equations. Let's take a look at some of the interesting things, because hopefully we get to the point where we don't even need to write this table anymore. And we can see that this 3/5 is reversed here to become 5/3. Those are reciprocals. But I hope that you're also seeing this. Eyes on the screen. In this equation, F is all alone. But here, it's being multiplied by that 5/3. I'm going to move this so that we're more consistent. It's there. And in this equation, the D is multiplied by 3/5. But in this equation, the D is alone. So, eyes on the screen and really open your ears. Is the only change I'm making just changing it to its reciprocal? No. We have to be paying attention to all of the changes. We're changing the 3/5 to its reciprocal 5/3, yes. But we're also switching where those variables are. And that's the other important part. For 6 and 7, we're asking two questions. It's important to know how to write equations, because then we need to use the equations to solve problems. Like this one. If we need to feed the shrimp for 10 days, how much food will we need? Before we even answer that question, I want us to figure out which of these two equations is going to be better. So when I read through this, I see if we need to feed the shrimp for 10 days, how much food will he need? So the real question that we're asking is how much food, right? Or what is F going to be equal to? So when I take a look at this equation, I can see that F is all by itself. That's the equation that I want to use. Because if I use that equation, F equals 3/5 D, I'm telling you right here that the D is going to be 10. So all I'm doing is taking that D, turning it into a 10, and then with that 10, I just have to multiply by 3/5. And that's going to give me what F is equal to. You have fast fingers on the calculator typing this in, solving problems with our calculators and with equations. What did you get, Chandon? This is true. F equals 6. That's abstract. Can we make this abstract answer quantitative? What does that 6 represent? What does it mean? Go ahead, Chandon, again. Exactly. And that's why I like using variables that match the situation. F for foods. When you see F, that reminds us it's 6 grams of food. I walked you through the first one. You're doing the next one with your groups. So online learners, you're going to pause the video, answer question 7. All right, this is what this should look like. This time I say we have 300 grams of food for the tank of shrimp. How many days? That means I want to know what's the days? Or in other words, what is D equal to? Look at your equations. Which one has a D all by itself, ready to answer the question? Our second equation, right? So that's the one that we're going to use. F times 5/3 is equal to D. Or if you wanted to use this version, that's fine too. And I know, because it tells me right here, that 300 grams of shrimp food, that tells me that F is equal to 300. So I took that F and I plugged in 300 in its place. So I have 300 times 5/3 is equal to D. So D, and D is equal to CJ. It is equal to 500. So with just 300 grams of food, we'll be able to feed that shrimp for 500 days. That's even more than a year. A year and a half. Okay. Now it's time to summarize. If Kiran rode his bike at a constant 10 miles per hour, his distance in miles, D, is proportional to the number of hours, T, that he can ride, or that he rode. He can write the equation D equals 10T. With this equation, I'll wait. With this equation, it's easy to find the distance Kiran rode. Why is it easy to find the distance? Because the D is already by itself. All we have to do is take the time that they give us and multiply it by 10. We can also rewrite the equation. These are just using the kind of the tips that we've practiced. And it looks kind of funny here, so I'm just going to rewrite it here. T equals 1/10 D. Notice what's happening here. We see the 10 and we see the 1/10, right? And we see the D, but now the D is not alone. The D is multiplied by 1/10. Because now I have T alone. And before, T was multiplied. So look at all those changes. This version of the equation tells us that the amount of time he rode is proportional to the distance he traveled. And the constant of proportionality this time is 1/10. This form is easier to use when we know his distance and want to know the time, how long it took, because the T is already alone. So we just take the distance and multiply it by 1/10. When two quantities, x and y, are in a proportional relationship, we can write the equation y equals k times x. And we would say that y is proportional to x. In this case, that number k and the course is the corresponding constant of proportionality. So we have k here, k is the constant of proportionality. But we can change things up. We can kind of reverse things. And we can show that x, which was not alone before, is now alone. And the k is now its reciprocal 1/k. In this case, we would say that x is proportional to y and 1/k, oops, wrong color. 1/k is the corresponding constant of proportionality. Again, that relationship is reciprocals. This is going to be incredibly helpful as we get to this cool down. An albatross is a large bird that can fly 400 kilometers in 8 hours at a constant speed, using d for distance in kilometers and t for the number of hours. An equation that represents this situation is d equals 50t. I didn't make you write the equation this time. There's not a table. We can't reverse columns. All we have is just this equation. First question. What are two constants of proportionality for this relationship? Raise your hand when you know. If you're struggling, we literally just highlighted it on this previous page. Doesn't that equation look an awful lot like this? Do you see the constant of proportionality right there in this equation? What's the constant of proportionality here? Emma? 50 is one of them. And now that I know that 50 is one of them, what is the other one going to be? Stephen. I'm sorry? It is not 100. Help him out, please, Sam. It is 1/50th. What is the relationship between these values? We've said it about 4 times today, and I think like 104 times this month. What is that relationship, Luke? Reciprocals. Are we using any different numbers than the ones we already had? 50 is really just 50 wholes, or 50 over 1. So am I using any different numbers? No, I'm just flip-flopping them. So we already have one equation, d equals 50t. I want you to write a separate equation. We already know what the constant of proportionality is supposed to be, right? What is that equation? I need to change that reciprocal, or change the constant of proportionality to the reciprocal. But as we have mentioned, that's not the only change. Are you brave enough? I've heard, Trinity. Perfect. T equals 1/50th d. Here d is alone. Now, in this equation, d isn't alone because t is alone. We did it. We made it. 7.2.5, practice problems is your homework. That's it. We'll see you next time.